welcome again. Thank you so much. I wish I could speak to each one of you individually for 10 minutes, and thank you for being here. If it weren't for you, this society would really not exist. After listening to my presentation yesterday, my wife gave me a little bit of advice. She said, look, honey, don't try to be too intellectual. Don't try to be too witty. Don't try to be too cute. Just be yourself. Last time I spoke to you about the problems with the compromise of theistic evolution. Today I want to take it a little bit differently, but let me remind you of two things that most of the speakers mentioned yesterday. Number one, God's Word does not allow for either the concept of evolution or theistic evolution. God's Word does not allow for evolution or theistic evolution. Secondly, scientifically, there is no visible difference between evolution and theistic evolution. Scientifically, there's no visible difference between evolution or theistic evolution. They're really the same thing. You know, my friend Zeb heard a sermon. You're saying, I heard this yesterday. No, it's a different sermon. It's a different sermon. The pastor was speaking on, again, Genesis, and he had two different quotes here from Genesis. First, Genesis 2:7. Then the Lord God formed the man of the dust of the ground and breathed into his nostrils the breath of life, and the man became a living creature. And then we know the unfortunate and sad story in Genesis 3. And God ends Genesis 3:19, by the sweat of your face you shall eat bread till you return to the ground. For out of it you were taken. For you are dust, and to dust you shall return. Well, this made a huge impact on Zeb. He thought about this idea often. And a few days later, Martha's in the kitchen preparing lunch, and she hears Zeb screaming his head off. Zeb screams a lot. She rushes upstairs. She finds Zeb. He's lying flat on the floor, and he's looking underneath the bed. And Martha says, Zeb, what are you doing? And Zeb says, Martha, have you looked under there? Someone's either coming or going. Thank you. By the way, I'm so glad we taped this, because I'm going to show that to my students. You know, you tell a joke, people laugh. That's kind of strange, isn't it? Okay. I have a story for you. Maybe parents or grandparents, you can relate to this story. So you're in the other room, and suddenly you hear a crash. And you come into the room, and you see this. Now, you confront your 10-year-old, and your 10-year-old says, Mom, Dad, Grandma, Grandpa, thank goodness you got here. What do you mean? What happened? Well, you see, you know about those two black holes, right, that we recently discovered? Well, as the confluence of those two black holes set up a gamma ray burst, and then a superstring expanded from that black hole, went right through our living room, crashed that lamp to pieces as I watched helplessly. Now, wait a minute. You're laughing. You did not see what happened. You don't know exactly what went on there. How do you know it wasn't a natural occurrence? Well, you say, based upon history and reasonableness of the argument, I think you really did it because, Joel, I see you with your Dodger jersey on, and I see that baseball, and I really think you were throwing it in the house and you knocked that lamp down. That does appear to be a reasonable explanation, doesn't it? Even though you didn't see what happened at the beginning. Well, let's investigate that a little bit today. People love cat pictures, don't they? Oh, look, it's Grumpy Cat. Cool. Here again is my honest skeptic. What I want to reach out to and who I want to interact with is the honest skeptic. Someone who's willing to ask questions, engage in dialogue, and has an open mind such that they can consider consequences. So, what about the honest skeptic who I don't know. Maybe I don't even believe in God. Maybe I accept evolution. Maybe it's possible that God did use evolution. I really don't know. How do we respond to the honest skeptic? Here's what I want you to think about. I believe that the best way to respond to the honest skeptic is using positive creation evidences. There's nothing wrong with pointing out the deficiencies in evolution or the deficiencies in theistic evolution. There's nothing wrong with that. And oftentimes that's a good tactic in certain ways. But I'm going to encourage you to think about framing this in a positive sense. The reason for that is this. Let's say you walk up to somebody and they say, hey, I'm a big baseball fan. And you say, well, what's your favorite team? And they say the Los Angeles Dodgers. The Dodgers? Those dirty, I can't stand those people. Well, immediately you've just met a friend. You've influenced people. They say, oh yeah, you're right. Those are, of course not. Even if we have some qualms about our favorite team, when somebody says something bad about them, we just automatically get our shankles up. That's human nature. Rather than taking that approach, how about when somebody comes up to you and says, oh, you don't accept creation, do you? You don't believe in God's word, do you? Yes, I do, and if you don't, you're going to hell. Wait a minute. Yeah, that's helpful. What if we say, oh, how about you explain to me why you accept evolution? And then I always say, that's interesting. Can I share with you a few reasons why I accept the creation model of origins? So you might find it helpful to phrase this in a positive sense. Let me try to illustrate that for you today. What I'm going to do today is I'm going to take you on a trip down memory lane through the previous 5 conferences. Can we do this in only the 6 hours that I have here? By the way, we're familiar with this verse. We heard it a couple times yesterday. For his invisible attributes, namely his eternal power and divine nature, have been clearly perceived ever since the creation of the world in the things that have been made. So, it is easy, apparently, according to Paul speaking, that we can illustrate God's creative acts in a positive sense. Why? Because it's obvious. We'll just nudge this a little bit. This is an important point. I would really like you to remember this. Creation is a reasonable idea. It's a reasonable model of origins. Some people want to say, that's the craziest, inane thing that I've ever heard of or seen. As a matter of fact, when you investigate it using the evidence and using the tools of logic, you can clearly perceive that it is a more reasonable explanation. When that lamp was broken, you did not see what happened. Is it more reasonable to assume that there was a natural phenomenon that did that? Or is it more reasonable to assume that there was an intelligent, in this case, careless act? Even though you didn't see what happened, there is a more reasonable explanation. So let's investigate those. At our first conference many moons ago, by the way, if I say a number of years, do you believe that is actual years? If I said this conference, okay, well, that's another thing. At the first conference we held here, we dealt with issues of the origin of the universe. And we had 2 world-renowned astrophysicists speaking at that time, Dr. Danny Faulkner, Dr. Don DeYoung, talking about the origins of the universe. They're both creationary scientists showing how, yes, it's legitimate that God created the heavens and the earth. Let me just pick on one evidence here. This is the evidence of design. We could spend a lot of time talking about design in the universe. As a matter of fact, my evolutionary friends talk about this all the time also. Sometimes they have to say it's not real design, it's just apparent design. As a design engineer, I have no idea what that means. As a computer scientist, I don't know the difference between apparent design and real design. It's design. It's the same thing. Here is the design argument in a nutshell. Now, when I'm talking to my students, they have no idea what this is. Okay? I tell them, it's a transistor radio. What's that? Sort of like an iPod. Oh, got it. Got it. The only thing is, rather than being digital, it was analog. And you know, with an analog tuner, if you ever did one of these, you know, you're trying to find a station, you turn it a little bit, it's kind of staticky, and then all of a sudden, then it comes in clearly. So we have to fine-tune that frequency in order to be able to hear it clearly. There are dozens, no, hundreds, no, thousands of these finely tuned and crafted parameters of the universe. There are just many, many examples of fine-tuning. There are factors, there are parameters that are just right for not only the existence of the physical universe, but also for the existence of life, and also for the existence of intelligent life, and also such that we could know the universe. That line of reasoning blew Einstein away. Einstein, who was not a creationary scientist, said, the fact that the universe is comprehensible is a miracle. Let me just give you a couple of these things. First of all, let's think about objects in the solar system. Think about the distance between solar system objects. Think about the distance between the Earth and the Sun, between the Earth and the Moon, between the Earth and the other planets, the existence of a huge planet like Jupiter out there protecting us. There are so many conditions that are just right. If they weren't here, we wouldn't be here. The size of the Sun, Earth, and Moon combined with their distance means that the angular size of the Sun and the Moon as viewed from Earth is the same. That's amazing. That's why we have eclipses. My wife and I were privileged to see the full eclipse in Kentucky last year. Awesome. The only reason that happens is because of the angular size. My colleague, Dr. Danny Faulkner, has analyzed every other planet along with their satellites and has determined there's no other planet that eclipse can occur on other than planet Earth. That's just interesting, isn't it? You also know that if the Earth were a little bit closer to the Sun, we wouldn't be here. You think it's hot today? Why don't you go to Venus? It's a little hotter there. Lead exists in a molten state on the surface of Venus. If they were a little further away, if you think Wisconsin is cold in winter, you ought to go to Mars. Really cold. We are in what even evolutionary scientists call the Goldilocks zone. Planet Earth is just right. A little closer, too hot, no life. A little further away, too cold, no life. We're just right. That's nice. Think about Earth's atmosphere. Several of the planets in our solar system have an atmosphere. Earth's atmosphere is unique. First of all, it's transparent, so that it allows good radiation from the sun. It allows solar radiation, heat, and light. But yet at the same time, the constituent factors in the atmosphere, such as ozone, help to block out some of the harmful things, the horrible UV, A and B, at least part of those kinds of things. So our atmosphere is just right to allow good radiation in to block out much of the harmful radiation there. The sun's spectra is just right for life. Think about the moon. Do we need a moon? We do. No moon, no life. Bigger moon, smaller moon, closer, further, no life. 2 moons, no life. What's going on here? The moon does a lot of different things. One of the things the moon does is it regulates tides. Fisher folk, twice a day, you got the tides up and down. Those tides are not just interesting, but they're important to do things like cleanse the tidal basins. We would not be able to produce nearly as much oxygen if we couldn't cleanse the tidal basins. If the moon were much closer, our tides would be catastrophic. Twice a day, California would be underwater. Many of you say, no big deal, right? Now, I do happen to be a California native, so it might be a big deal for me. If the moon were farther away, there'd be no tides. The tides would not be powerful enough to cleanse the tidal basins. No life on planet Earth. Now, you could say, well, these are just happy coincidences, and sure, it's there because we're here. But someone like me, a creationary scientist, looks at that and says, this is powerful evidence for design. A God who purposefully planned these things for our benefit. By the way, speaking of the moon, one day I asked students, which is further away? Just make sure you understand scales of distance. Which is further away, Florida or the moon? And I had one student say, duh, can you see Florida from here? As an amateur astronomer, one of the things that bugs me is this thing that people throw out that say the sun is just an average star. That is baloney. The sun is not an average star. As a matter of fact, in the most recent galactic survey, there are some folks that are desperately looking for other stars like the sun. How many stars in our galaxy? 5? Many, okay? Billions and billions, perhaps. Now, we haven't surveyed every one yet, but we've done a lot. We've found 2 that people think are kind of close to the sun. Don't let anybody tell you the sun is an average star. It has many unique properties. Did you know that photosynthesis is tuned to the wavelength of the sun? If the sun were bluer or yellower or purple, it wouldn't work. Photosynthetic processes are tuned to the sun. You know this. You ever try to grow plants indoors with an incandescent light bulb? Don't work. Water. I was a physical chemistry major as an undergraduate. Water is a unique, bizarre substance. As far as we know, it's the only substance under normal temperature and pressure that has this funny property. When water goes through a phase change from liquid to solid, what is he talking about? When water freezes, you know what happens? Yeah, it expands. Its density decreases. It's the only substance we know of that does that under normal temperature and pressure. Is that important? You bet. If water didn't do that, if ice did not float, no life on planet Earth. Soon, the lakes would freeze over, the rivers would freeze over, because see, in the summertime, we know this in Wisconsin, right? The ice goes away because it's on top. If it was on the bottom of the lake, insulated by those layers of water, after a while, it would all build up. Soon, no life on planet Earth. Now, when I asked my physical chemistry instructor, why does water do that? The answer was hydrogen bonding. Okay? Why? We don't know. We don't know. It's okay. I don't know either. There are so many unique, finely tuned parameters and factors in the universe. If things weren't like this, if some of these were just a little, if the gravitational constant was just a tiny bit different, we wouldn't be here. If the size of the proton were a tiny bit smaller, we wouldn't be here. Is it all just happenstance? I would say that the evidence points strongly to a designer. Which makes more sense? Which is more reasonable? That things were designed or they happened by chance? Imagine, for example, that you went into an electronics store like Best Buy, and you had all the flat screen TVs up there. And you look and you see, they're all tuned to ESPN for, what's that game people play with their foot? That's weird. Why don't we call it football? Okay. Anyway, they're all tuned to the World Cup. And you say, that's bizarre. How did those all just by chance get? Well, no, of course not. Somebody sat there and tuned them to the right thing. Reasonable, perfectly sensible. At our second conference, we explored issues of the origin of life. And we had two world-class scientists talking about issues related to the origin of life. And how can we investigate this from a creationary perspective? One evidence that we could put out in a positive sense here, unfortunately, is my favorite one. So now I have to follow this closely, otherwise I'll just speaking off the cuff and we'll never get anywhere. And that's information theory. Think about this. Does it make more sense that the origin of life was a natural process, or does it make more sense, is it more reasonable that it required an intelligent act, and certainly a supernatural act? Which is more reasonable? So, let's investigate information theory. If you're an engineer, you've heard of this, but that's not what Claude Shannon developed in the mid-20th century. I'm going to call that Shannon theory. It's not truly information theory because Claude Shannon had nothing to talk about or say about information. So let's talk about information just a tiny bit. Information, where is information? Here's a big conundrum for my materialistic friends and colleagues. Your brain, hello, where's my brain? Whew, no wonder you didn't know. It's hard, okay? Your brain contains lots of information, right? Your brain is matter. Your brain is matter. What about the information? Is the information matter also? No, absolutely not. As an informational scientist, absolutely not. There's a difference between stuff, matter, and information. It's hard to visualize this, of course, because we always see information coupled with matter. I mean, it's kind of hard to think about, well, how can I think without my brain? Let's investigate this just a little bit. Let me give you the synopsis of information theory. This is what information theory says. Information comes from intelligence. Information comes from intelligence. If you want to generate information, you must have intelligence to do so. Intelligence generates information. Let me use an example with you. Think about a book. You open up the book, there's some matter there, but there's something else. There's information content there. See, information, the content that you read in that matter, points to an intelligent cause. Nobody reasonably concludes that if you have information that it somehow created itself, right? We're not concluding that books somehow self-assemble in warm little ponds in northern Wisconsin. There are no warm little ponds in northern Wisconsin. Instead, if you have a book, even if you've never met the author of the book, you know the information points to that particular author. And yeah, you knew I had to work Chuck Norris in here somehow, didn't you? Yes, okay. Speaking of information and Chuck, you know that Chuck Norris doesn't read books. He stares them down to get the information he wants. Of course, we laugh at that because it is absurd. And we laugh at that because we know information comes from intelligence. So what does this have to do with origins? And what does this have to do with life? Well, you're all carrying lots of information with you right now. I'm not just talking about the mental states that you're generating. I'm talking about in all the trillion cells in your body, there is a huge information repository, and that's DNA. And as we learned a couple years ago, especially with my good friend, cell biologist Dr. Kevin Anderson, DNA is more fantastic than we can even imagine. When I was a little boy, DNA was just an information carrier. Huh. Oh, and by the way, then there was that time that there's all this junk in the DNA. Yeah, that's bunk. DNA is not only information, it's also a program. What we call in computer science an object-oriented system, the combination of function and program and data and information in one thing, that's DNA. And it's even more than that. Do you know, DNA, stop, read your script, mister. DNA, think of it this way. Do you know that proteins get transcripted both forwards and backwards? Do you know that there are some sections of the DNA that are read one direction and it produces a functional protein? That same strand is read backwards, produces another functional protein. I want you to write a book that you can read and derive understanding from both forward and backward. Oh, and you know what? It does it in multi-dimensions. It's not just a linear thing. It exists in 3, and now we believe 4 dimensions. Of course it does. It exists through time. If you think, wow, DNA, this is incredible complexity and information. This is why today computer scientists are trying to get information stored on genetic material. It'd be a lot better than semiconductors. All right, let's see if I can put this together in one meaningful way. Here's a point to think about. There's a difference between matter and information. I want you to do this. Nobody's doing it. I'm telling you to do something here. Now you're saying, well, I don't know what it means because you told me it's a secret code. That's right. You see the matter, but you don't know the information. By the way, this is a secret code. I know today, students, you want to send a note to your friend, you just text them. When I was a little boy, I couldn't do that. You had to write it on a piece of paper. And man, if you wrote Mr. Parks is a fink, and Mr. Parks caught that note, you were in serious doo-doo. So we wrote it in a secret code. Oh, good. All right, now you don't have to remember this, but this is the secret code. Just make the tic-tac-toe. See, if I had a box, that'd be an E. If they had this greater than sign with a dot, that'd be an X. And so, ooh, pretty tricky, right? So now, given that you understand the code, you can make sense of the matter. Do it. No, I won't ask you to do that. This is what it says. Too late now. Too late now. You can't leave because you didn't know. So what's the point? Information is not inherent in matter. Matter, stuff, can't generate its own meaning. Information has to be imposed on matter. Did the book write itself? There was an author. Did DNA create itself from matter? There was an author. That's called science. Would anybody who investigates a computer think it's just hardware? If you were advanced but knew nothing about a computer and investigated this, you would conclude that the only thing here is hardware. You cannot see software. You can't see it. It's informational. It rides on top of the matter that exists there. But we know that a computer is not just matter. It's matter plus information. And where did that information come from? Even if you could conclude somehow that a computer could naturally develop itself, that information content had to be imposed upon it by an intelligent agent. All right. Let's see if I made my point. You didn't know there was going to be a test today. You should have known better. I'm a teacher. Here's my origins quiz. I'm going to show you an object that is 100% natural stuff. It's just matter. Did those objects develop naturally? How can you say that? I can investigate that using the tools of a physical chemist. I can tell you that's granite. How can you possibly conclude that that's not just matter? The answer is information. You recognize the information being presented to you as four faces. Is this some kind of natural law? Do granitic rocks have to produce faces of former United States presidents? Yeah, it's Newton's 17th law of motion. No, there is no such natural law. The reasonable thing to say here is someone, an intelligent agent, added that information to the matter. There was a question yesterday. I won't get into this entirely deeply. Talk to me about it afterwards if you're interested. And I have to tell you, this is really controversial. Few evolutionary scientists would talk about this, although Karl Popper did. Many creationary scientists don't like this either. But I think it's helpful to understand that there are different kinds of sciences. Mathematics is oftentimes touted as a type of science, and I agree with that. And I'm not talking about the difference between physics and chemistry and biology, but I'm talking about this. As a physical chemist, I did something called operation science. I took samples of things, I put them in a mass spectrometer, and I looked at the different ratios of the isotopes in there. Operation science is what chemists and physicists and geologists and other people do today. Operation science, sometimes called empirical science, works in the here and now. Its two hallmarks and characteristics are observation and experimentation. So if you can observe it and you can conduct an experiment, you've got operation science. This is cool stuff. I like it. We do it all the time. Operation science has a limitation, however. What were the two hallmarks? Observation, experimentation. If we're dealing with the origin of the universe, or the origin of life, or the origin of diverse life, or the origin of human beings, can we observe that? Can we run an experiment on it? I don't think so. I could be wrong. Therefore, I follow this idea. There are other scientists. I heard the term before, historic science. It goes by other kinds of names. Forensic science is a popular name for this. I prefer the term origin science. This is what we do all the time when something happened in the past and we want to come to a reasonable conclusion of what happened. We find a dead body. What happened? Did this person die of a natural, what a scientist would call a secondary cause? Or was this person helped out of life to the afterlife by a nefarious intelligent agent? Was a person murdered? Right? Yeah. We're familiar with the shows, right? We see all the CSI type of things, and we know what happens there. Now, in origin science, we do operation science, but not to prove what happened, but instead to give us a reasonable explanation for what happened. So if you asked me as a creationary scientist, can I prove using science that God created the heavens and the earth? The answer is I cannot give you proof in the sense of operation science. However, I can give you evidence in the sense of origin science when you investigate it logically and reasonably would lead you to that conclusion. So, our next conference then, we investigated the origin of diverse life. We had an emphasis on dinosaurs here. By the way, this was held at our sister school, Concordia University, Ann Arbor. And again, we had several different specialists talking about the origin of diverse kinds of life. And let me just share with you one of the evidences that they gave. Again, think this way. Which is a more reasonable explanation for all the diversity of life that we see on planet Earth today? Is it more reasonable to assume this had a natural process? Is it more reasonable to assume that there was an intelligent cause for the diversity of life that we see on planet Earth? Fossils are interesting and exciting. If you didn't get to see one out there or you don't have one, I'm sorry, I'm sure you've seen some. Oftentimes, I've heard people say, well, fossils prove evolution. In my view, you can't prove either model scientifically, but I would say fossils are actually a much better evidence for creation when you think about exactly what a fossil is. See, my evolutionary friends look at fossils as the birth certificate of organisms over time. But I want you to think about what a fossil is. A fossil is something that is currently dead. Rather than being a birth certificate over time of different organisms, fossils are actually the death certificates. A fossil is a once living organism that is now dead. What do we see? Lots of dead things. Is that consistent with the unfortunate effects of the curse? Is that also perhaps consistent with a worldwide cataclysmic judgment at the time of Noah? I would say yes. But let's look at some other things. First of all, you can't look at a fossil and not be amazed at the design and complexity there. My evolutionary friends would say these two fossils are extremely old, hundreds of millions of years old. Yet it seems to be a non-Darwinian event. Rather than being simple, these are amazingly complex things. For example, this is the compound eye of a trilobite. I believe that trilobites are only thousands of years old. There are none around today, but they only lived thousands of years ago. In the standard evolutionary view, trilobites are 500 million years old. But yet these creatures defy an evolutionary explanation. Why? Because of the complexity. Their eye is this is it. These are amazingly complex creatures. Right at the beginning, and for an evolutionary scientist, that would be right at the beginning, the Cambrian explosion, the very earliest and simplest types of life. Sea urchin. Again, my evolutionary friends would say these things are hundreds of millions of years old. Now, they still exist today, but they appeared in the rock record hundreds of millions of years. They're very ancient, old types of life. I suggest that these are complex creatures. Scientists have wondered, how do sea urchins get around? I mean, they don't have an eye. How can they possibly get around? We have discovered that there's the same protein that's in your eye that allows you to see that's all over the body of a sea urchin. There are many scientists who say the sea urchin somehow sees with its entire body. That doesn't sound simple to me. That sounds complex. Did you know that other scientists are investigating the immune system of the sea urchin? That sounds bizarre. The immune system of a sea... That's giving us some insights on how to think about the human immune system. Is this some kind of simple form of life? Extremely complex. Think about not only the diversity in the fossil record, but the discontinuity within the fossil record. There are lots and lots and lots of things in the fossil record, and they are all grouped by kind. Let's see, this is my silly way of thinking about this. See if this helps. For example, we know today that there are cats and there are dogs. We won't have that debate. I'm a dog person. It's okay if you're a cat person. I've come to live with that. There are cats and there are dogs. When we look at the real evidence in the fossil record, when we look at real kinds of life on planet Earth today, we see distinct kinds. Now, we see many different examples of dogs, breeds, and the same with cats. But if continuity, if the evolution model were true, why do we have these distinctions? Why do we have cats and dogs? If the evolution model were true, we should have cats and cogs and dats and dogs. See how that worked? You should have things in between here. But we don't. In both the fossil record and in real life, we have discontinuity. Now, as we heard a few years ago at this conference, creationary scientists are trying to figure out what is a kind. It is not a species, but realize species, genus, species, family, order, etc., that's all a human-made thing. And right now, that's very much based upon evolutionary presuppositions. Most creationary scientists, like my colleague Dr. Jean Leitner would say, she believes that the kind is somewhat like what we'd call a family in the current biological taxonomy. So, sometimes people try to characterize God. Well, who was it? Famous evolutionary scientist, I think it was Dobzhansky, said, God must have loved beetles. He made 250,000 different species of beetles. No. He made a kind, which did diversify. Diversification is part of the creation model. Natural selection was proposed by Edward Blyth, a creationary scientist before Charles Darwin. It's part of the model. Why? It's God's backup mechanism. It's a way for the kind to survive in a changing environment, in a changing ecosystem. Just think about the fossil record. First of all, there are two different ways to think about it. Legitimately, you could think about the fossil record as a vast period of time, old on the bottom, young on the top, and then as we go through time, I see new creatures developing. The birth certificates. And that's what my evolutionary friends say. But there's another legitimate way to look at the fossil record, and that is as the death certificate. Creatures died in ecological zones where they were living. And we know that the vast majority of fossils are marine creatures. These things died where they were living. They were buried all in ecological zones, and that's what we have today. While not all of the fossils were produced by the flood in Noah's day, many of them were. We know it takes water, lots of water and lots of sediment, not lots of time, to produce a fossil. We have that in the flood of Noah's day. Fossil graveyards are everywhere. The Cambrian explosion. My evolutionary friends look at this as biology's Big Bang. In evolutionary timescale, approximately 560 million years ago, the diversity of life sprung on planet Earth. The Cambrian is just another type of life. We see things here in the Cambrian that we have no modern analog for. There are weird things. There are body plans, phyla, that only exist here. We have no modern analog for. It's just, what do we see? We see God's immense creativity. Right at the beginning, all different kinds of life. That seems reasonable. Let me just share with you one other evidence, because I know you've heard of this and this comes up often, and I want to make a critical point about this. And that's the idea of homology. Homo, same, structure, homology. For example, today in the here and now with Operation Science, if you investigate I'm going to call this an arm, but I don't know if you call that an arm in a whale or not. Let's investigate the forelimb of mammals. And we see they all have a similar structure. One bone here, two bones there, joint here. They all share a similar structure. We call that homology, similar. It says here that couples start to look like each other the more time they spend together. Is that your way of telling me you're having an affair with someone really ugly? What happened after that was really ugly. Folks, homology. I know if you've heard of that, you've said, oh, this is a classic evidence for evolution. Yes. Why? Because common ancestry, common descent. The reason my evolutionary friends say that this looks similar is because there was one ancestral mammal that got passed down to all the others. Okay? That seems like a reasonable explanation on the surface, doesn't it? Sure. There's another reasonable explanation for homology. One could be common descent. The other could be common creator. Perhaps there was a common designer who had a great idea and then used this for different kinds of life. By the way, everything has to exist in the same ecosystem, right? We all live on a common planet. Would it make sense that a common creator then used common plans for the life that exists? If you think DNA is a fantastic thing like I do, would it make sense to reuse it? You bet it would. Here's a very important point I'd like to share with you. We all live in the same universe. Evolutionary scientists, creationary scientists, we have the same evidence. We have exactly the same evidence. What's different? Interpretation. Homology because of common descent, or homology because of common designer. Same evidence, different interpretation. So question, which is more reasonable? Let me illustrate this in another way. Some of you have seen this before. What do you see? Ah, okay. Some of you may see an older woman. Okay? Some of you see an older woman kind of looking down. Okay? Others of you may see a younger woman kind of looking back away from us. If you see an older woman, then here's her mouth, here's her big nose. She's looking down. Here's her big nose and her mouth, and this is kind of her bonnet and a feather in her hair or something like that, right? If you see a young girl, then here's her nose, here's her eyelash, she's kind of looking away, and this is her cheekbone, and she's got a choker chain on her neck there. Same image. Same image. We come away with two different perspectives. And a lot of this would depend upon your starting point. Can I share another thing with you? I love science. I'm a scientist. I love science. Especially if you're a Christian, please be careful. Science has some limitations. Do not look for natural scientific explanations for supernatural events. Do not look for natural scientific explanations for supernatural events. I have some wonderful friends and colleagues, good Christians, creationary scientists. They spend lots of time trying to decide, how'd that flood work? How'd the flood of Genesis 6 through 9 work? I don't know. But this thing I do know. It was a supernatural event. If you're looking for some natural causation or whatever, I just want to be cautious of that. So, conference 2 years ago, we took a look at the origin of human beings. Again, we had several different experts there talking about the origin of human beings and why it's more reasonable to deduce that human beings were created rather than developed naturally. My favorite evidence for this is something I'm going to refer to as the image of God. The image of God. There are differences, qualitative differences between humans and all other forms of life. There's a huge gap, a huge qualitative gap between human and other forms of life. I'm going to summarize that in something I call the image of God. Theologically, originally the image of God is we were holy. We were in perfect communion with God and with husband and wife. And we blew that. But we still maintain a tarnished image of God. And in addition to the theological idea of holiness, the image of God includes other human capacities that are not shared by animals. Let me illustrate some of those. First of all, symbolic language. Animals communicate. Animals can explain certain things to each other. My wife is an equine scientist. She could get our horses to do things just by wagging her finger. Okay, ask her how she does that. I don't know either. We could communicate with animals, they could communicate with us, but no other animal has a grammatical, symbolic language. You cannot, as smart as my dog is, I cannot tell her my dog's name is Boole. That's a weird family. That's a 19th century Christian mathematician, George Boole. We're weird. Boole, tomorrow I want you to go fetch the stick and then bring it in, and then we'll give you. No. The a priori, the idea of grammar, no idea what's happening there. There's a huge gulf between animals and human beings. I'll impress her with a palindrome. Madam, I'm Adam. Eve. Women are always better. Shorter, that's good. That's good. I'm not going to spend a lot of time on this because I know that at least one of the other presenters today is going to talk about this concept of abstraction. At least I hope she does. When she talks about that, pay attention. This is an important human trait and characteristic. Okay? But I'm going to share this. Abstraction means the capability to simplify. The human beings can do this. Other animals cannot. For example, Einstein's general theory of relativity. We would hope, if somebody's going to talk about that, that we'd ask somebody to abstract that, to simplify it for us. Well, I asked my oldest daughter to do this, so she did it. Would you like to see Einstein simplified? There's actually a deep truth here. But anyway, abstraction is simplification, a unique human attribute, trait, and characteristic. It would make sense if we were created by the most creative intelligence in the universe that human beings would be sub-creators. This is the Antikythera mechanism. What we believe, we used to believe that this was from about the time of Christ, and I've seen that it's been dated about 200 BC now. This was thought to be one of the first analog computers, a device that would predict not only tides, but also solar eclipses and other amazing things. Human beings are wonderfully creative. He gave them dominion over land, sea, and air, and right away they built the Edsel, the Titanic, and the Hindenburg. Well, I guess we hasn't always done it right, but we're pretty darn creative. I would be remiss if I didn't mention this concept of beauty. I think many of you understand the point that's being made here, and it's not just because some people argue, well, I don't find that beautiful. The whole point is the idea that we do recognize a transcendent, the whole concept of beauty. At our conference last year, we talked about the age of creation. And I know this is the most difficult one for people. And there's no possible way anybody can convince somebody that the universe and the earth is young quickly. Especially when, if you're like me, you went up through a public school system from kindergarten through graduate school, and that's all you ever hear. Trying to get a different mindset to the age issue is the toughest thing, I believe. We had some great experts tackle this last time. Let me just share with you some reasons why we might consider a young age for the universe and earth. Thanks for not laughing at my grandchild. No, I'm just kidding. Just kidding. It's difficult to correlate size and age, although many people want to do that. Let me just give you a couple evidences for you to think about and consider why the universe and the earth and life might not be billions and hundreds of millions of years old, but might actually only be thousands of years old. When we take a look at geologic formation, Darwin took ideas of Lamarck and Hutton, two geologists. The idea was called uniformitarianism, and applied it to biology. Uniformitarianism is long, slow, gradual. And that would initially seem to make sense. You would see a little river flowing, and it carves a canyon, and we think, whoa, it must have taken a long time to do. The problem is we have evidence that it doesn't take a long time. You're likely familiar with Mount St. Helens. My family and I lived nearby there during the eruptions. I lived in Oregon in the 1980s. And this is a canyon that was carved through 600 feet of strata. I was a graduate student at Oregon State at the time, and I remember some discussion among geology students and professors saying, if we didn't know better, we could date that at hundreds of thousands, if not a million years. You know how long it took to carve that canyon? 1 day. Oh, wait, what does he mean by a day? I mean a solar day, a period of about 24 hours. A pyroclastic flow, a volcanic flow, ripped through that canyon from Mount St. Helens, carved it 600 feet deep, 1 day. Does it take a long time to produce geologic formations? It does not. It doesn't necessarily take a long time. For those of you that were here last evening and saw the video from the Creation Research Society on soft tissue and dinosaur, this is another indicator that dinosaurs, classically dated between 65 and 225 million years ago by my evolutionary friends. As a creationary scientist, I say dinosaurs are thousands of years old. Well, since we've found soft tissue with biomolecules in them, how long can they last? And if you're a biologist, you know they don't last very long under environmental conditions. Let me work an analogy with you just in case. Maybe this is helpful. Here's my analogy. So imagine you're walking through the desert and you crest a sand dune. It's hot. It's like Wisconsin right now. It's hot, it's dry, and you crest a sand dune, and suddenly before you, by the magic of PowerPoint, you see, whoa, there's an ice castle. Whoa. And you walk up to this ice castle. Yeah, it's ice, it's cold, it's dripping, it's melting everywhere. Some of the spires are coming down. You say, whoa, that is strange. That's unusual. That was unexpected. Now, it's there. We got to explain it. There's two ways we can explain this. One, we can say, well, golly, that ice castle's got to have been hundreds and hundreds of years old. There's got to be some kind of special thing in the sand right here that's preserving the ice so it doesn't melt. You say, that's weird. A more reasonable explanation is that ice castle has not been there very long. It was just created not that long ago. It's melting, and it's going to go away. That's the soft tissue argument. My evolutionary friends are desperately seeking some natural preservation mechanism, iron or whatever, that would preserve the biomolecules that are there. Nope. The more reasonable explanation is this material is relatively young. It's on the order of thousands of years, not tens or hundreds of millions of years. That's the more reasonable argument. I know you've seen strata. My wife has grown to love this. We travel a lot. We drive through road cuts. Stop! He pulls a car over on the side of the road, taking pictures of stuff, you know. You drive through a road cut, what do you notice about the strata? It's always straight. It's always straight. Look at the different strata, and look at the connection there. Straight, 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 straight. It's always straight. What's that mean? This deposition happened rapidly. These layers were laid down one over the other rapidly in a short amount of time. If this layer was laid down and then stayed there for 10 million years, what would we see? Erosion. It'd be up and down, right? A river would run through, wind, tornado, whatever. It would be up and down. We don't see that. If you want to, you could assume that either something weird happened or who knows what, but when you look at the strata layer, you can tell that thing happened rapidly. If it happened rapidly, does it have to be old? Nope, it does not. My colleagues in the Creation Research Society decided to do something that nobody thought of. Carbon-14, we heard a little bit about it last time. Carbon-14 is kind of like a ticking clock. Once something dies, then the carbon-14 is not ingested, and then it goes away. Well, nobody thought to check a diamond for carbon-14 because there shouldn't be any. Carbon-14 has a very short half-life of 5,700 years. If this anything was more than 100,000 years old, there'd be no carbon-14. And we know, of course, because of the De Beers commercial, that carbon-14 is millions of years ago formed and under the... Guess what? Carbon-14 in diamonds. When we date a diamond, like from the Arapa mine here with carbon-14, we find that they are thousands of years old. Interesting. What's the only way to absolutely, absolutely with clarity determine the age of something? Reliable witness. We'll assume the United States government's not faking us there, right? This was really minted in 2014. Got a stamp on it. What is the only way to know with certainty the age of anything? A reliable witness. I believe that in the biblical text, I have a reliable witness. I have someone who said not only when I created, how I created, what I created, but how long ago I created. I want to summarize this this way. This is my wife. She's an equine scientist. This is one of our horses. This is our pony. I'm going to encourage you to think about creation this way. I've blitzkrieged you with lots of things. Makes it sound like I'm smart, right? Don't believe it. Don't believe it. Nobody knows everything. Nobody knows the answers to every question. I get asked questions a lot by my evolutionary friends. Well, what about this? What about that? I don't know. But this is what I'm going to encourage you to do. Pick one thing. Pick one thing. Pick one evidence. And when they ask you a question about, what about Washaw, the sign language ape, say, I'm sorry, I just don't know. But have you considered this? Okay. Have you thought about this aspect? If someone was going to ask my wife a question and bring up evolution, she would say, let me share something. That's interesting. Let me share something with you about the horse's hoof. And when you look at the design of the horse's hoof, you cannot reasonably come to any other conclusion than there was a master creator. Just pick one evidence, learn it, and share it. You're going to yell at the other person? You're going to say that idea is stupid? No, I'm not. I'm going to listen, and I'm going to say that's interesting. But have you thought about this? Why? We want to point to the Creator. You're not going to win friends and influence people by yelling and screaming. You might win friends and influence people by listening and then by presenting a reasonable argument for why you believe what you believe. The question is, are there other Goldilocks planets that we've discovered? There are people that are claiming there are some in the zone, but the planets are incorrect. They're either rotating wrong or they're gas giants or whatever. As far as we know, conclusively, there are no other Goldilocks planets in the solar system, in the galaxy, in the universe. Tag on, your other question is, well, how do we know this? How many different solar systems are there in the universe? This is why today, because of this fine-tuning argument, that some evolutionary scientists propose the multiverse. This is not the only universe that exists. There are an infinite number of universes. We live in the correct universe, the one that works. This is the multiverse idea. Okay? When it's first proposed, people kind of snickered. But today it is fairly well accepted. This is natural selection of universes. You need enough universes, roll the dice and roll the dice, and oh, that one worked. Okay? Well, guess what? There's not enough odds in this universe, so we need other universes to even out the odds. Nothing wrong with that. It's philosophical. It's not operation science. Great question. So the question was, we mentioned Creation Research Society has an initiative called eKinds, trying to determine what is a kind. But how does that relate? I went through this too quickly. I apologize. Natural selection. When you hear the term natural selection, you probably think immediately of evolution. Natural selection was an idea proposed by a creationary scientist 25 years in its modern form, before Charles Darwin, as a conservation mechanism. Diversity happens. Your children don't look exactly like you. Your children are thankful for that, right? When dogs have, there are differences. There are. It's called genetics. We can't help it. So there is diversity. This is something the Creator built into the idea of a kind. Natural selection actually allows for the survival of kinds. Imagine a hypothetical animal. Let's call it a, I can't even make things up. Let's call it a polar bear. So you have this polar bear. God made the bear kind. They're all polar bears. They're white. They have really thick fur. So they have babies. They all look like themselves. White, really thick fur. Imagine the environment changes. It's no longer cold. It's no longer sunny. It's hot and dark. Those polar bears are going to die off. Please don't keep polar bears in South Florida, except for in a zoo, right? They've got to have a condition. If all the bear kind were exactly the same, if the environment changed, they'd all be wiped out. But natural selection allows for diversity. So some of the kind may have died off because of maybe disease or changing environment, but others would survive in spite of it. So here's the answer to natural selection. Natural selection is a real thing. It's a real deal. It actually works. But it does not create a new kind of life. Genetically, it cannot. It would require the increase, the natural increase of information. As an information scientist, that doesn't happen. The information that's there is moved, shuffled, etc., so we have some diversity. So you got diversity with natural selection, but not new kinds of life. So the comment was Darwin's classic example of the finches on the Galapagos. Yes, they absolutely were a variation within the kind. Darwin was exactly correct. But Darwin then extrapolated to think, well, finches and robins all came from this, and yeah, no, that did not happen. The comment is, in an evolutionary model, the formation of the solar system, where did all the water on planet Earth come from? Lots of different models have been suggested, nothing that seems to have been workable hypothesis so far. Does it make more sense that God created planet Earth with lots of water? Yeah. I'm always amused by the fact that some of my evolutionary friends say, you believe in a global flood, where's all the water? I said, 71% of the Earth's surface is water, and which is a bigger distance? The top of K2, the tallest mountain, or the bottom of the Marianas Trench? Did you know if we pumped all the water out of Lake Superior to cover North, Central, and South America to a depth of 2 inches? There's plenty of water here.